All right, let's just jump right in. What if I told you that one of the biggest, most fundamental rules of physics, a rule we all thought was locked in, has just been completely shattered? And the proof? It isn't light years away in some distant nebula, it's inside every single cell of your body right now.
You see, for as long as we've been grappling with quantum mechanics, there's been this one core assumption. It was like a line in the sand that physics just didn't cross.
And the idea was pretty simple, really. All those bizarre, powerful effects from the quantum world, particles being in multiple places at once or being instantly connected across huge distances, well, we thought they could only happen in super cold, super isolated, sterile labs. They were just way too delicate for the warm, wet, chaotic mess that is a living cell.
Well, about that. According to some absolutely groundbreaking new research, that assumption, it hasn't just been challenged, it has collapsed. Entirely. What we all thought was physically impossible is now looking like it might be a fundamental feature of life itself.
Now, to really understand why this is such a bombshell, you first have to appreciate what we're calling the impossible problem. It's all about the huge, huge challenge we humans face just trying to build our own quantum computers.
The number one enemy, the big boss, is this thing called decoherence. Basically, the second a quantum system gets jostled by heat or vibration, or literally any interaction with the outside world, poof, it snaps back to our boring, classical reality, and all that quantum magic just vanishes.
Okay, just look at this comparison. It says it all. To fight that decoherence, we build these room-sized $100 million facilities and cool them down to colder than deep space. And then you look at a living cell. It's warm, it's wet, it's incredibly crowded and noisy. It is the literal opposite of everything we thought was necessary for quantum mechanics to work.
So that leads us to the big central mystery, right? If our smartest scientists with our most advanced labs can barely pull this off, how in the world has life been doing it effortlessly for billions of years?
Well, it turns out the answer might have been hiding in plain sight this whole time, inside one of the most common molecules in your entire body. This is where we start to crack life's secret code.
Let's talk about tryptophan. Yeah, that's the amino acid everyone blames for their post-Thanksgiving dinner nap. Turns out this very humble molecule has a pretty extraordinary secret life.
A physicist at Howard University, Philip Curran, made a truly stunning discovery. He found that inside the microtubules, think of them as the structural skeleton of our cells, tryptophan molecules are arranged in these special networks. And when they absorb UV light, they do something absolutely incredible. They trigger a state called quantum superradiance. Instead of just being a disorganized crowd of molecules, they start acting as one, like a perfectly synchronized choir, becoming a single, powerful, coordinated quantum entity.
And the scale of this quantum behavior, this is where things go from just fascinating to completely mind-bending. Because it looks like life isn't just a simple quantum system. It might be a cosmological scale computer.
Let's put this into perspective. A normal neuron in your brain fires off signals at maybe 1,000 operations per second. That's pretty fast, right? But these quantum processes happening inside your proteins, we're talking up to 10 trillion operations per second.
Just let that sink in for a moment. That is 1 billion times faster than a neuron's signal. This means that life isn't just dabbling in quantum computation, it's doing it at speeds that are pushing the absolute physical limits of our universe. It's unbelievable.
And this isn't some fringe theory. When one of MIT's top quantum computing researchers, Seth Lloyd, heard about this, his response was that the computation happening in living systems is vastly more powerful than anything we've ever built.
But here's where it gets truly wild. Curran did the math. He calculated the total quantum processing power of every single living thing that has ever existed on this planet, over 4.5 billion years. And the result? It's a number so huge it's on a cosmological scale. It might actually rival the total computational capacity of the entire observable universe.
So, if our cells are running these unbelievably powerful quantum computers, what exactly are they computing? And this question, well, it takes us straight into one of the deepest mysteries in all of science, consciousness itself, the ghost in the machine.
For about 30 years, Nobel laureate Sir Roger Penrose and Stuart Hameroff have had this theory, that consciousness isn't just about brain chemistry. They proposed it actually comes from quantum computations happening in those very same microtubules we were just talking about. For decades, it was mostly dismissed, as fringe science. But just look at this timeline.
A brand new paper, slated for 2025, now concludes the theory is experimentally supported.
In fact, the paper itself says that this quantum model solves some of the biggest problems that classical models of consciousness have been stuck on for years. All of a sudden, the fringe is becoming the frontier.
So what this means for you, for me, for all of us, it's profound. It suggests that your inner world, your subjective experience, that feeling of you, it might not be some illusion cooked up by chemistry. It could be a genuine quantum phenomenon.
So how did this happen? How did life get this world-changing ability? This question is leading to what's being called the Great Convergence, and it leaves us with two very, very different ways of looking at everything.
Think about it. How did life solve a problem that stumps our best and brightest physicists? Well, there are two main views here. The first is that blind random evolution just stumbled upon this impossibly elegant solution after billions of years of trial and error. The other view is that this wasn't an accident at all, that this incredible capacity for quantum computation was actually built into the fundamental architecture of life from the very beginning.
But, regardless of how it got here, this convergence of biology and quantum physics is about to unlock a revolutionary future. We're talking about quantum biosensors that can spot a disease in a single cell, drugs designed using quantum principles, even brain-computer interfaces that don't just read electrical signals but tap directly into quantum coherence.
It's like the researchers at the University of Chicago said, that hard line we always drew between the quantum world and the living world, it's starting to dissolve, right before our eyes.
So, we're left with this one last thought to chew on. We've just learned that the oldest and most fundamental system we know, life, has been running on the most advanced operating system we can possibly imagine. So, if the very code of life is quantum, does that change how you see, well, everything?